We're continuing on our journey here to write a basic language computer program that will divide two polynomials. And in particular, we're trying to take this polynomial right here, and this will be a general nth order polynomial, a sub n of x times x to the n plus dot 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 all the way down to a sub 0. We're dividing it just by a, a simple linear polynomial. We're dividing it by something that looks like b1x plus b0 right here. So we're dividing it by this, and the idea being that the p sub n of x then could be written as p sub n of x is equal to this linear polynomial times the quotient polynomial q sub n minus 1 of x plus the remainder. In this case, the remainder is not a function of x, and the reason for that is that we're only dividing by a linear polynomial. If we were dividing by a quadratic or a cubic polynomial, for example, in general, r would also be a function of x. But in this case, it's a constant. Okay, so we're looking in particular for the polynomial q sub n minus 1 and r. And I use the subscript n minus 1 here for q because q is an n minus 1 order polynomial. If p is an nth order polynomial, q is an n minus 1 order polynomial. Now, previously we have deduced the following general expressions for the coefficients of the q sub n polynomial. Said that q sub n minus 1 is equal to a sub n divided by b1. Remember, a sub n is this coefficient right in here. We also have then q sub n minus 2 is equal to this expression, 1 over b1 times a n minus 1 minus b0, and here the value of qn minus 1 appears from the previous expression. We keep going all the way down until we finally get the constant coefficient for the polynomial q, which is given by this expression. So I want to now write computer code that I can insert in my program that will execute these computations. And I have some sample computer code right here on the right. Let's look and see what this is doing. The first statement I have here, 160, is just a remark where I'm noting that the order of the polynomial q is 1 less than the order of the polynomial p. Okay, now I'm defining a new variable I call nm1 for n minus 1 is equal to n minus 1. Okay, pretty clear notation. Now I'm going to execute each of these equations right here. I say q of n minus 1, q of n minus 1 is equal to a sub n divided by b1. It's equal to a sub n divided by b1. Remember that a sub n was defined in the computer code as an array variable. Okay, now I go into a for loop to execute to evaluate the rest of these terms right in here. I have for I equal 1 to n minus 1, and I set k equal to n minus 1 minus I, and now I set the expression q sub k is equal to this thing right in here. So notice, for example, when I is equal to 1, okay, k is equal to n minus 2. Okay, k is equal to n minus 2. So I have qn minus 2 is equal to 1 over b1, here's the dividing by b1 term here, times a sub n minus 1. Okay, so it's q of n minus 2 is equal to a of n minus 1 minus b0 times q of n minus 1 right here. Remember, if we put k plus 1, here we have k is equal to n minus 2 when I is equal to 1. So k plus 1 is n minus 1. and then here's the divide by bn. So this statement right here executes first when I is equal to 1, it executes this one, then I equal 2, it executes the next one, and so on, all the way down to the last statement when I is equal to n minus 1. When I is equal to n minus 1, k is equal to 0, so q sub k is equal to q sub 0, the 1 over b1, times a sub 1. Well, if k is 0, then k plus 1 is 1, so that's a sub 1 right there, a sub 1. And then minus b0 times q sub 1. Okay, so that's how that set of computer code operates. So let's look at the program that we have right now as it stands. We have this, this is our Chipmunk basic window. We have this program right in here. Okay, so this is where we left off. Let me renumber this and then list it. Okay, so here's what I have. Pull this up here. And I want to add another variable to hold the Q coefficients. So I'm going to change 10. Okay, statement number 10 is going to become dimension, dim, A10, comma, Q, and just to emphasize that Q will be of order 1 less than order A, the polynomial P. The polynomial Q will have an order of 1 less than the polynomial P. Let me dimension this 9. Okay, so the coefficients for Q are going to appear in that array variable. Okay. Now with let's see. Lists. Okay, so here's my 10. Now I want to input these extra statements right in here. 160. Let me move this over. There. So move this over right here. So I'm going to put in statement 160. Remark, the order of Q of X is 1 less than the order of P of X. So that's statement 160. Well, statement 170 is nm1 is equal to n minus 1. Statement 180 is q of n minus 1 equals to a of n divided by b1, 190 for I equals 1 to n minus 1, 200, k equals n minus 1 minus I to 10, q of k equals a k plus 1 minus b0 times q k plus 1 divided by b1. And 220 next I list. Okay, I have this dimension statement. I jump down here, I have the remark statement. nm1 equals n minus 1, a sub n divided by bi, 1 to n minus 1 minus I, a k plus 1 minus b0 times q. Okay, this looks like it might work. Let's type run. The degree of the polynomial is, say, 4. Okay, coefficient for 1, 1, 1, 1, and then finally a0 is 1. Now the two coefficients for b1 and b2, 1 comma 1. Okay, so here's my polynomial, x to the fourth plus x cubed plus x squared plus x plus 1. The divisor polynomial is 1 times x plus 1. I probably need to fix that somehow. Okay, so now we need to have some statements in here where we actually are going to print out the values for the polynomial q of x. Okay, let me see. How we can do that. Let me pull open my Chipmunk Basic window here. List. Okay, now let's just check out to see. Let me just print out q sub k right here. I'm going to open this thing right here. Okay. Now let's type. Let's go 230. Let's print. Say we're going to print the quotient polynomial. Print. Okay. 230. Print. The quotient polynomial is and now I want to go through and print out the coefficients. So I'll do 240 for I equals 0 to n minus 1, n minus 1. Now I'll set 250 k equals n minus 1, n minus 1 minus I. 260 print q sub k semicolon quotation x to the k quotation semicolon k, and then 270 next I. Okay, let's try run. Degree of polynomial is, say, 4. Return 1, 1, 1, 1, and then 1. 1 comma 1. Okay. So here is these last set of commands where I printed out the polynomial q sub k. And it's saying here that the polynomial, that the x cubed coefficient is 1, the x squared coefficient is 0, the x coefficient is 1, and the constant coefficient is 0. Now, I'm a little bit, I'm trying to figure out why it's also printing out the value k right here. So see, I have the k still in there, right there. So I want to get rid of that. 260, do print qk semicolon quotation x to the quotation semicolon k. Now let's try running this. Run. Degree of the polynomial is 4. 1, 1, 1, 1, 1, 1 comma 1. Okay, so now I would suggest you might want to try to do some synthetic division to see if this is the right answer. So we'll continue with this discussion of polynomial division next time.